So hello and welcome friends to our channel Entromech, and here we discuss about basic mechanical engineering concepts. So guys, we have started a new series, and in this series we are particularly discussing about the SolidWorks and the use of its simulation to make you understand the basic things and how they are applied in the designing. So today's our topic is, you can read like, use of revs. Now whenever you enter into the industry you will come across these brackets a lot. Now these kind of brackets are used for, say, mounting of the different components and so many other things. So why we are using the ribs? So we can check out this with the simple simulation with the help of SolidWorks. So if you want more such kind of content, please subscribe to the channel and hit the bell icon so that you can get the notifications. So without wasting time, let's get. So here you could see the window. This is the SolidWorks window, and let's check out what it is. Now here you could see the different orientation, different things in the first. Now let's see the different windows over here. Now this is the first case. We have a reeb. Now actually this reeb will be made up of three different say parts which will be bolted here. So, and it will have like mounting holes over here, and some part will come on this like this. Now the cylinder has mounted over here, right? Now it will have some, say, load, or it will be some like resisting some kind of load. All these things will be there, right? And let's check out what happens in this case. And this is the second case where we have like added some ribs over here, these two ribs over here and one rib on the back side, and the same component has mounted over here. Now we will see how this application of ribs affect the results, right? So let's start with say simple ribs, right? So this is our part, and it will be like kind of made up from three different pieces. I have shown for the sake of convenience as a one part. You can make it from one part, but it is very costly, and in industry mostly it is made up of like welding three parts or like bolted. So we are going to the simulation here, and we will add a fixture. So what we are doing, we are fixing the bottom, right? So the bottom will be fixed on, say, machine bed with the help of bolts, right? There will be some bolts on this face, so the bottom will be fixed, right? And then what we are doing, we are applying some force. So we have seen that there will be some pneumatic cylinder on this face, so there will be some force. So we are adding force on this face, and let's take a force of 1000 Newton. So we have applied a force of 1000 Newton on this face. The next thing is we have to choose the material. So let's choose the material. We have a different kind of materials. Let's take the ASI 1020 material, right? And you can see the Young's modulus and yield strength. Now hit the next button and run the simulation, right? So we have got the results. We have like stress and displacement. So let's check out the stress and displacement. The stress value we can see here, it is the maximum stress is like 5.60 into 10 raised to 7. We can see over here, right? So that is the maximum stress which is getting induced in the body, which is still lesser than the yield strength, but that is the maximum stress which is coming in the body, right? And let's check out the displacement. So the displacement maximum we are getting like 2.52 into 10 raised to minus 1, so that is 0.25 mm. So that is the deflection which is causing at this end, right? And Because of that, what will happen in the assembly, you could imagine there will be the deflection of this much amount, and because of which the whole assembly will get displaced by this amount, right? So what we can do, so let's check out now the second case. What we have in the second case is we have added the ribs. You can see over here, and let's go for the simulation. We are doing the same thing. We will fix the bottom part, right? And then we will apply the same amount of force on the body, 1000 Newton. And now let's check out the results. We have used the same material, right? What we have changed here, we have added the ribs, right? The simulation has completed and we have got the results. So let's check out the results. So displacement and stress. Let's check out the stress. You could see the stress value 5.54 into 10 raised to 7. The stress value has reduced, and what we are interested is the deflection. You could also see the stress region has also changed, and the most of the part is blue. That means the stress is less in this part. You could see the blue value over here. And let's check out the displacement. Now the displacement, you could see 5.4 into 10 raised to minus 2. So the value is 0.054. So the displacement has reduced drastically. In the previous case, if you remember, the displacement was like 0.25 and now the displacement is 0.054. So displacement has reduced drastically. Here it is now only say 5 micron. In the previous case it was sorry, in this case it is like 50 microns, and in this case it was like around 250 microns. So this much amount has reduced. Now you can understand the use or the application of the ribs and why they are widely used on such kind of brackets, right? So again we will just compare the results over here, right? So displacement has reduced like 0.05. So you have now understood the use of the ribs and how we have reduced the deflection with the help of ribs. So with the use of this simple simulation, you can just apply your engineering knowledge and you can check out the different results. You can just vary the size of ribs, you can just change the orientation of the ribs, you can change the number of the ribs and how they are affecting the results, you can check out. So this is it, the today's session. I hope you liked the session, and if you have any doubts, please do write into the comment section. Until then, stay home, stay happy. Thank you for the patient listening. Thank you.